Hello, welcome everyone. Thank you for joining us this afternoon. I'm Greg Panagiotatos. I'm a software engineer from the HPCC Systems platform development team. I'm joined today by Rodrigo Pastrana, an architect also on the HPCC Systems platform development team. Today, we're going to discuss the logging challenges encountered by containerized applications and how HPCC Systems handles these challenges and the solutions available to our community. We'll demonstrate and focus on a simple elastic stack-based solution provided by HPCC Systems. As we embarked on our journey to the cloud, we encountered several challenges by the containerized mode of operation. One major challenge is the lack of persistency, the difficulty of accessibility, and decentralization of application-level logs. In bare metal environments, application logs could be written to files at known locations, and those files are expected to persist. Developers, admins, users, and services could reliably access those log files by simply knowing the fixed location and name. In containerized environments, those files would be ephemeral, and the location and storage is potentially distributed and/or dynamic. All this adds up to eventual loss of log data and potentially cumbersome or difficult log access. Following widely accepted containerized methodologies, our component log information is routed to standard output streams rather than to local files. This approach provides our community the flexibility to manage the logs in an appropriate manner based on their particular needs. Out of the box, Kubernetes exposes our component logs via the get logs command. However, these logs are only temporarily available and can be difficult to analyze and monitor at a larger scale. Remember, these logs are ephemeral and may be lost if the pod is evicted, if the container crashes, or if the node dies. HPCC Systems logs are available to Kubernetes and trivially reroutable to other log managers, such as Elasticsearch, Azure Log Analytics, persistent files, and others. We provide an optional feature which facilitates casual users to deploy a lightweight Elastic Stack instance for log management. This feature can be accessed from HPCC Systems Helm chart repository and requires minimal effort to deploy and set up. And now we'll have Rodrigo demonstrate this process.
Deploying a lightweight Elastic Stack instance for the purpose of managing HPCC Systems component logs is a two-step process if using the Elastic for HPCC logs Helm chart. Once deployed, the Elastic Stack instance does require a couple of one-time manual setup steps, so we'll walk through that process as well. The environment for this demo is a one-node Docker desktop with Hyper-V on a Windows 10 machine, but the same process can be applied to other container-based environments. We'll start by adding a local reference to the HPCC repository, which we'll use to deploy the Elastic for HPCC logs chart. If you've previously added the repo, it's a good idea to update the repo to ensure we're getting the latest versions of the charts. At this point, deploying the Elastic for HPCC logs chart is as simple as issuing a helm install command. We'll call our deployment myelk, and we reference the Elastic for HPCC logs chart in the HPCC repo we recently added. This deploys the Elastic Stack instance, which is comprised of several components, which includes FileBeats, which performs the actual capturing and forwarding of the log data from the pods to Elasticsearch, which is the data store, and Kibana is the user interface. At this point, we can review the pods to make sure that they've deployed successfully before moving forward. Also, note an HPCC instance has been pre-deployed for this demo. Using kubectl get service, we see in this environment, Kibana's service is located on localhost 5601. Please note Kibana is declared as load balancer for ease of out-of-the-box access, but the user should control external access to this service. We'll use Kibana's web interface and its tools to view and manage the HPCC logs. So let's connect to the Kibana service. Again, in our example, it is on localhost 5601. Kibana exposes available data via the Discover section, so we'll navigate there from the main menu. As Kibana's interface points out, we have to create an index pattern in order to view data. We can follow the Create Index Pattern shortcut provided by Kibana. The first page of the New Index Pattern wizard displays a list of available indexes. We should see at least one index with the file beat prefix if any of the HPCC component logs have been forwarded to Elasticsearch. In our case, we see the indexes which suggest our pre-deployed HPCC Systems logs are already being forwarded to our Elastic Stack. The new index pattern requires a name pattern which matches all related index names. For our example, we can use filebeat star. So let's input that pattern into the name field and move on to the next step. The index pattern wizard suggests designating a primary timestamp field, so we'll use the @timestamp field. And we'll click the Create Index Pattern button to finalize the process. We can now navigate back to the Discover section to view our log data. From the main menu, choose Discover. The Discover section displays the available data for a given time frame and exposes mechanisms to help us focus on the information we're interested in. By default, the log entry documents and all of their associated metadata is displayed. The first thing we might want to do is refine our view to display the actual log entry message only. This means we'll find the field named message and add it to our view. On our left-hand pane, we're provided a list of all available fields associated with our log data. Let's find the message field in the list. Once the field is located, we can hover over it and click the plus button, which adds it to our view. You'll notice the crowded view is now clearer and only showing the contents of the message field. These log messages originate from multiple components and pods, so we might want to add the source of the log message as well. Let's add the Kubernetes container name field. We've now isolated the log messages along with their source. Hovering over a cell in the view exposes filter shortcuts which allow you to quickly filter in or out that specific value. Let's quickly filter out all ECL Watch log entries by clicking on the minus button. This applies the filter, which is reflected on the view, and now we see non-ECL Watch originated log entries only. Let's edit the filter just to illustrate how easy it is to set custom filters. Click on the filter recently created. Choose to edit it. Let's change it to only include ECL Watch related log entries. To do this, we'll simply change the operator from is not to is. ECL Watch. Save it and refresh. After updating the filter, our view is updated with ECL Watch related log entries only. Now, if we want to search for a particular keyword which might appear in the log message, such as the transaction summary, also known as TX summary, we can use the KQL search box to do full text search on the message field. Let's copy TX summary and paste it into the search field and refresh. At this point, we can navigate through the logs, execute simple filters and queries, but you might have noticed we're limited by the fact that the entire log entry is treated as an unstructured string blob. Even though each log entry contains subfields such as job ID, target audience, log event, the actual timestamp, and other bits of information. This layout prevents us from performing more efficient exact term queries. Fortunately, we can extract this metadata and expose it in dedicated searchable fields by reformatting the default index layout via Elasticsearch ingest pipelines. Creating a pipeline to enhance the log data layout is optional, but likely very useful. A simple pipeline definition and detailed instructions are provided in the HPCC platform GitHub repository. Let's navigate to the repo and take a peek at the Helm Managed Logging Elastic README page, which provides detailed instructions in a very convenient predefined pipeline and an Elasticsearch command, which can be issued to create a basic pipeline. I will now copy this predefined pipeline. Kibana provides a convenient shell where we can issue this command directly to Elasticsearch. Let's navigate to the Dev Tools from the main menu on the Kibana interface. Here we can paste the pipeline command into the shell and press the Send Request button. If successful, you can expect an acknowledged response. Now let's navigate to the Pipelines section to confirm our pipeline has been created. We can see our new pipeline and it can be expanded to confirm it contains the definition we provided. In order to associate FileBeat's output with the pipeline, we need to modify the Elastic for HPCC logs FileBeat Helm chart values. Let's go back to the HPCC Systems GitHub repo where we can find the exact command we can use. Let's copy the Helm upgrade command since Elastic for HPCC logs is currently deployed. Otherwise, we would use the Helm install command provided immediately above. And now we issue that command on our local command shell. By the way, this command references a values YAML file we've provided with the appropriate change to the FileBeat config. Back at the Kibana interface, navigate to the Discover section again. At this point, any new log messages would have been processed by the new HPCC pipeline we recently created. We can confirm this by the presence of new HPCC.log prefixed fields. The subsections of the message field are now mapped to dedicated fields. The contents of the message field is now structured and can be queried directly. We'll add a few of the fields to our view, such as HPCC log message, the job ID, timestamp, and audience. We no longer need the old string message field. Let's create a new filter to query for logs associated with a particular work unit. Click on the Add Filter link. In the dialog, pick the hpcc.log.jobid field from the pull-down menu. Let's set the operator to is. And let's specify the value we're interested in. Save it and update. Here are the results. Now we're able to search more efficiently and to build exact term filters, but we're also able to apply the Kibana tools, such as visualizers, to any of the newly created fields. As an example, I'll create a simple visualization with the HPCC.log job ID. Let's navigate from the main menu to Visualize Library, create New Visualization, and choose the Lens options, which allows us to drag and drop fields and let the system suggest different visualizations for us. Let's look for the hpcc.log.jobid field. And let's drop it in. We're likely not interested in the unknown job ID value, so we can click on it, which creates a new filter for only unknown job IDs. Let's negate the filter to is not to ensure we only get actual values. Let's also add the hpcc.log audience field, and we'll see what Kibana can come up with as visualizations.
All right. Thank you for that, Rodrigo. This demonstration we just watched illustrated the simple steps necessary to deploy Elastic for HPCC Systems logs and the powerful log management features it provides. However, I want to reemphasize the fact that Elastic is only one of several possible solutions. If, for instance, Azure is your cloud provider, as the chart on this slide illustrates, our component logs redirected into Azure and exposed through the AKS log analytics workspaces. This is possible because we make our logs available to standard output streams, as mentioned earlier. Now, this concludes our presentation this afternoon, and I want to take a moment to thank you. We hope you found our presentation both helpful and useful, and we will now open the floor to any questions. If you think of any questions later, we provide you with our contact information, as well as some other useful resources here on this slide. Once again, thank you.